Imagine standing next to a machine so heavy that it can crush tiny pockets of air hidden deep inside a road. Now imagine that without this machine, highways would crack apart, airport runways would fail, and entire cities would grind to a halt. Every smooth road you've ever driven on owes its life to one giant steel beast, the road roller. But here's what nobody tells you. Building one of these machines is a manufacturing story that begins thousands of kilometers away, deep beneath the surface of the Earth. Think about this. A modern road roller can weigh more than 20 tons, generate crushing forces measured in tens of thousands of kilograms, and operate in temperatures hot enough to bake asphalt like bread in an industrial oven. Yet every bolt, every steel plate, every hydraulic hose must work together with astonishing precision. One hidden flaw could lead to catastrophic failure on a busy construction site. And this is where our journey gets truly extraordinary. Over the next few minutes, you'll follow the road roller from raw or buried underground to a fully tested machine ready to shape highways around the world. You'll see molten steel glowing brighter than a sunset, robotic welders throwing showers of sparks, and quality tests so brutal they would destroy ordinary machines in minutes. What happens next surprised even experienced engineers. Because the most important part of a road roller isn't what most people think it is. Most people see a road roller as a construction machine. Manufacturers see something very different. They see thousands of kilograms of carefully engineered materials arriving from multiple continents. The steel alone often accounts for more than half the machine's total weight. Before a single component reaches the factory floor, an invisible global supply chain has already traveled farther than many people will travel in their entire lives. The journey usually starts with iron ore. Some of the world's largest supplies come from Australia's Pilbara region and Brazil's Carajás mining complex. Massive haul trucks carry ore containing roughly 60 to 67% iron content. Each truck can move hundreds of tons in a single trip, kicking up clouds of red dust under blazing sunlight. The roar of engines echoes across landscapes, so large they look almost alien. But raw ore cannot become road roller steel overnight. The material travels by rail to ports, then crosses oceans aboard bulk carriers longer than 3 football fields. Some shipments travel more than 10,000 kilometers before reaching steel plants in Asia, Europe, or North America. Imagine the smell of salt air, the vibration of ship engines, and mountains of ore sitting silently inside enormous cargo holds. Every kilometer adds cost, energy consumption, and environmental impact. Steel is only the beginning. Road rollers also depend on copper mined in countries such as Chile and Peru. Copper flows into wiring harnesses, sensors, electronic control systems, and alternators. Even a medium-sized road roller can contain tens of kilograms of copper hidden beneath its steel shell. Most operators never see it, yet without it the machine would remain lifeless metal. Then comes rubber. The tires used on pneumatic rollers often begin their story on plantations in countries such as Thailand, Indonesia, and Vietnam. Workers harvest latex from rubber trees before processing plants transform the material into industrial compounds. The smell changes from fresh vegetation to hot rubber and chemicals. By the time the finished tire reaches the assembly plant, it has already passed through dozens of manufacturing stages. Hydraulic systems bring another layer of complexity. Manufacturers source high-grade alloy steels containing carefully controlled amounts of chromium, molybdenum, and nickel. These elements improve strength, wear resistance, and fatigue life. A hydraulic cylinder may look simple from the outside, but its materials represent decades of metallurgical research. Most people never think about this, yet these hidden components perform millions of movements during a machine's lifetime. The environmental footprint behind these materials is enormous. Mining operations consume energy, steelmaking releases significant carbon emissions, and global shipping burns vast quantities of fuel. Some modern manufacturers now incorporate recycled steel, renewable electricity, and cleaner production methods to reduce impact. Yet the scale remains staggering. Building a machine designed to create roads requires an astonishing amount of resources before manufacturing even begins. And now comes the moment where scattered raw materials transform into something entirely new. Iron ore, copper, rubber, alloys, electronics, and fuel have all completed their long journeys. They stand at the gates of the factory, waiting for the first spark, the first weld, and the first blast of industrial heat. What happens inside that factory determines whether a road roller survives decades of punishment or fails before its work even begins. The moment the raw materials enter the factory, the noise level changes instantly. Overhead cranes glide across the ceiling carrying steel plates that weigh several tons each. Forklifts weave between workstations while cutting machines throw bright showers of sparks across the floor. You can smell warm metal, machine oil, and the faint ozone scent created by high-powered electrical equipment. And this is where a road roller finally begins to take shape. The first major step involves cutting structural steel for the chassis. Computer-controlled plasma cutters slice through steel plates often between 10 and 50 millimeters thick. Temperatures inside the plasma arc can exceed 20,000 degrees Celsius, or more than 36,000 degrees Fahrenheit. The cutter races across the steel at speeds approaching several meters per minute, leaving behind glowing edges and a trail of molten sparks. What looks effortless is actually one of the most precise operations in the entire factory. Next, enormous press brakes bend the steel into shape. Some machines apply forces exceeding 500 tons to create perfectly angled frame sections. The steel groans under pressure, and the entire building seems to vibrate with each cycle. Workers constantly verify measurements because even a tiny error can affect the alignment of thousands of future components. Most people never think about this, but accuracy starts long before assembly begins. Now the factory begins building one of the roller's most recognizable features, the drum. Thick steel sheets are rolled into giant cylinders using heavy plate rolling machines. Massive rollers slowly force the metal into a perfect curve over several minutes. The steel creaks as internal stresses shift through the material. By the end of the process, flat sheets have become giant cylinders capable of compacting entire highways. The curved sections move to robotic welding stations. Welding arcs burn at temperatures approaching 6,500 degrees Celsius, or nearly 11,700 degrees Fahrenheit. Robots follow programmed paths with millimeter-level precision, while showers of sparks cascade onto protective barriers below. The smell of heated steel fills the air. What happens next surprised even experienced engineers, because a single weld defect could eventually destroy a machine weighing more than a small house. After welding, technicians inspect critical joints using ultrasonic testing. High-frequency sound waves travel through the metal searching for hidden cracks and internal voids invisible to the human eye. The process takes only minutes, but it can reveal flaws smaller than a grain of rice. Imagine spending hundreds of hours building a component only to reject it because of a defect buried deep inside the steel. That level of scrutiny protects the machine for decades. Meanwhile, another part of the factory prepares the vibration system. This hidden mechanism creates the pounding force that allows the roller to compact soil and asphalt. Precision-machined eccentric weights spin at speeds that often exceed 2,000 revolutions per minute. As they rotate, they generate powerful vibrations that can deliver tens of thousands of kilograms of compaction force. Without this system, a road roller would simply be a very heavy vehicle. Engine installation comes next. Depending on the model, diesel engines producing between 75 and 200 horsepower arrive from specialized suppliers. Workers lower these engines into the chassis using overhead cranes with astonishing precision. Hydraulic pumps, cooling systems, fuel lines, and electronic controls connect piece by piece. Every connection matters because this engine will eventually spend thousands of hours operating in dust, heat, and constant vibration. Then the hydraulic system arrives. Workers install pumps capable of generating pressures between 200 and 350 bar, or roughly 2,900 to 5,000 psi. Hydraulic fluid flows through precisely machined hoses and valves that control steering, propulsion, and vibration functions. During testing, technicians pressurize the system while searching for microscopic leaks. A single leaking seal can eventually shut down an entire construction project. The assembled machine now enters the paint line. First, workers clean every surface to remove oils and contaminants. Then robotic sprayers apply corrosion-resistant primer before adding the machine's signature colors. Large curing ovens heat painted components to temperatures often ranging between 160 and 200 degrees Celsius, or 320 to 392 degrees Fahrenheit. The fresh finish emerges glossy, durable, and ready to survive years of harsh outdoor conditions. Now comes final assembly. Operators install cabins, control panels, seats, glass, wiring harnesses, lights, and safety systems. Every switch, display, and joystick undergoes functional verification. The machine finally begins to resemble the road roller you would recognize on a construction site. But here's what nobody tells you. At this stage, the factory still does not trust it. Before the roller can leave the factory, engineers perform initial operational testing. Engines run for hours while sensors monitor temperatures, vibrations, fuel consumption, and hydraulic performance. The machine rumbles across test tracks that simulate real construction conditions. Every strange sound attracts attention. Every vibration gets analyzed. Because the next stage pushes the machine far beyond ordinary operation, and that's where the real challenge begins. Think back to where this journey began. Deep underground, iron ore waited in ancient rock formations. Copper rested inside distant mountains. Rubber flowed from trees growing in tropical heat. None of those materials looked anything like a road roller. Yet through mining, transport, metallurgy, machining, welding, testing, and engineering, they became one of the most important machines in modern civilization. Every time you drive on a smooth highway, land at an airport, or watch a new city rise from the ground, a road roller has almost certainly played a role. It doesn't receive the attention given to skyscrapers, bridges, or high-speed trains. Yet those projects depend on the compacted foundations and perfectly prepared surfaces that road rollers create. Most people never think about this, but entire transportation networks rest on the work of these machines. What makes this story remarkable isn't just the scale. It's the precision hidden behind the steel. Thousands of components must work together in perfect coordination while enduring vibration, heat, dust, rain, and years of punishment. Engineers calculate tolerances measured in fractions of a millimeter. Technicians inspect defects invisible to the naked eye. And skilled workers apply experience that no machine can fully replace. And this is where the road roller becomes more than a machine. It becomes a symbol of how modern manufacturing transforms raw materials into tools that reshape the world. From glowing furnaces hotter than lava to advanced quality control laboratories filled with sensors and computers, every stage represents decades of innovation. What happens next is something we often overlook. The machine leaves the factory and quietly goes to work, changing landscapes without demanding recognition. The next time you see a road roller moving slowly across fresh asphalt, you'll know the hidden story behind it. You'll know about the mines, the ships, the steel mills, the robotic welders, the engineers, and the thousands of decisions that made that moment possible. What appears simple from a distance is actually one of the most sophisticated manufacturing journeys on Earth. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.